On LR3-4, we're going to write proofs using flowcharts. We've been doing 2-column proofs. We're going to take a step back and do flowchart proofs instead, okay? Some kids really prefer these, and if that is you, when we get to the test, if you want to draw out a flowchart instead of doing the 2-column proof, that is totally a-okay. You can do that. Likewise, on the test, there is 1 or 2 flowchart proofs. I think just 1, actually. And if you would rather do a 2-column proof for that, you can absolutely do that. You don't have to use the flowchart. Okay, so it's just an option. Today you are going to practice doing them though. So if we go all the way back to our algebra proofs, I'm going to have some boxes, and each box is going to lead to another box. So in my first box, I have stuff written out. All I needed was eyeballs. So my reason, just like before, is given. Okay, my reason is going to go in the line underneath. Sometimes there's a line in the box, depending on which textbooks I stole the flowchart from. My next step would be to add 5. So that will lead me to 3x equals 155. On the line below, I'm putting in what step I did. I added 5, so that is the addition property of equality. Or you can put just addition prop or addition PE. And then I need to divide by 3, and I get a funky decimal. So I'm ending with x equals 51 and 2/3. Remember, when I do algebra proofs, I don't show my work because I'm a big kid now, so if I need to do work elsewhere, I should do that, but then erase it. I did division. So this is true by the division property of equality, or division prop, or division PE. Cool. We're going to do this with triangle proofs now. Okay, and you'll see some that go sideways, that go this direction, if I follow my little arrows. You will also, and I didn't give a good example of them, you'll also see them that go down. So you could start with like 3 boxes leading into 1 box kind of thing. When I look at this, I have 1 box that says given here. So I'm going to write my first given statement there. And the first thing I'm given is AR is congruent to ER. Then in my next box, they filled in AC is congruent to EC. I just need to know why. And if I look up here, that was my second given statement. So I'll use given as my reason below. And they were really nice to me. They told me, hey, RC is also congruent to RC by the reflexive property. Awesome. So if I mark up my picture, I've got AR congruent to ER, these 2, those 3. All 3 of those sides are going together to tell me which shortcut proves that those triangles are congruent. Okay, so I need all 3 of those parts to lead into these triangles are congruent. I have all 3 sides, so my shortcut is side, side, side. Once I have my triangles congruent by side, 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 I'm using, CPCTC to prove what I was asked to prove. So what I was asked to prove always goes in the last box. Angle E is congruent to angle A. On my next one, I'm told SE is congruent to SU. That's in my first box here. My reason is given because it was written out for me. I'm also given angle E is congruent to angle U. So that's these 2 angles. It was written out for me, so that is given. And then it's telling me, hey, use angles 1 and angle 2. So these 2. My reason is that vertical angles are congruent. Those 3 parts will come together to prove 2 triangles congruent by angle, side, angle. And here I have a choice. It'll be triangle if I do MES for my first triangle. M matches up with O. E matches up with U, so I have OU, and S matches up with S. If I had put ESM, I would need to put USM. If I had put SEM, I would need SUO. Okay, so you have to make sure that your letters match up in those triangles. And that's going to lead me into my last step, which I'm using corresponding parts of congruent triangles are congruent to prove whatever it was I was asked to prove. So that always goes in my last box. Cool. All right, the last one that we will do together, this time I have, on that very first line, I have M as the midpoint of AB. That was given. Wonderful. That's leading me to know that AM is congruent to MB. Okay, so this itself doesn't get me my triangles congruent, but it leads me to know some parts of my triangles that are congruent. So I've got AM congruent to MB because of that. Similarly, M is the midpoint of CD. Notice these are two different steps. Just because it's the midpoint of AB doesn't automatically mean it's the midpoint of CD. I had to know both separately. That was given because it was written out for me. That's going to lead me to know that CM is congruent to MD. My reason can be definition of midpoint. Some of you prefer to put M is the midpoint of CD. You can totally do that. In the flow charts, though, it's often fill in the blanks, so that they'll give you one or the other, okay? So just know that. And then when I look at this, my flow chart is telling me, hey, use some vertical angles. The only vertical angles I have in my picture are angle 1 and angle 2. So I'll say angle 1 is congruent to angle 2. All three of my triangle parts here are leading me to know some triangles are congruent. So if I say triangle AMC, AM matches up with side BM. Okay, so if AM are my first two letters, BM need to be my next two letters. And then my last side has to be D. I have an angle between two sides. So if I write my two sides, I need to write the angle between the two sides, just because it's between the two sides in my picture as well. My last box, I'm always putting what I was asked to prove exactly as I was asked to prove it. So AC is congruent to BD because corresponding parts of congruent triangles are congruent. Hopefully that was a solid enough explanation. I know it was a super quick lesson. If you have questions, pop into office hours or shoot me a Schoology message, or rewatch this video because your checkpoint is very similar.